Okay, pre-calc class, we are starting in our first chapter, first section, and today we are going to be looking at lines in the plane, and more specifically, we're going to talk about the slopes and how to find the slopes using graphs and by the formula. We're going to write some equations given 2 points and also given points and slopes. We're going to use slope-intercept formula of linear equations to sketch lines, and then we're going to find parallel and perpendicular lines and look at their slopes and how we can identify those using the slope. So here we go, the slope of a line. So we know if we're talking about the slope of a line on our coordinate axis, here's the line. Basically, y'all have had this before. The slope of the line is basically how steep it is. How far is it going up, or how shallow is, how flat is it, or whatever, the slope of a line, or the steepness. Okay, now more specifically, the slope represents the number of units the line rises or falls vertically for each unit of horizontal change from left to right. So how many units it goes up or down, right, as opposed to how many units it goes from side to side, from going from one point to another. Now, you've heard of that probably as rise over run. Okay. You've seen that a lot of times, how much it rises over how much it runs or goes to the side from point to point. But the more textbook definition here, if you look at this on a coordinate axis, and we've got generalized points. So one point we're going to call x1 and y1, the other we're going to call x2 and y2. Okay? And the way we find how much it changes up or down, you know, if we were actually using actual points, 2, 3, 4, 5, 1, 2, 3, 4. So let's say we had a point right here at, what is that, 1, 2. And we had a point right here at 4, 5. And this is the line I'm looking at. So this is 1, 2, and this is 4, 5. If I wanted to know how much this line goes up from here to here, it goes from where? 2 on the y-axis up to 5 on the y-axis. So to find out how much it goes up, you would just simply subtract, right? 5 minus 2, it goes up 3 units. So notice what they're doing, or what they will do, is, or what they're doing right here is they're saying this point y, we're subtracting that y from, or minus this y right here. That's the change in y. All right, same thing for the x. If I wanted to know from this point to this point, it goes over, I could count it. That's 3 units. 4 minus 1 is 3. Basically, they're subtracting the x coordinates. Okay, so that is what we call the change in x, the change in y. Could be the rise over the run, is another way to look at it. But as we go on, there we go. That's what we say. We're talking about you subtract the y, that tells you the change in the y coordinates. You subtract the x's, that tells you the change in the x coordinates. Slope is the ratio of these two changes, and we always do the rise over the run, like we said just before. So that would be, the rise would be the change in y over the change in x. So that is where we get our slope formula, which is y2 minus y1 over x2 minus x1. M is what we use to represent slope. That came from some sort of Latin word or something like that, is why they use M. But that's just traditionally now what we use in math for slope. But this is the mathematical formula to find the slope. So, and there it is. Slope of a non-vertical line through these two general points is the change in y over the change in x, or y2 minus y1 over x2 minus x1. All right, right here it tells us x1 cannot be equal to x2. And my question to you is why is that there? Can you think for a second and say, why can we not have x1 equal x2? Well, right here, if x2 and x1 were equal, when I subtracted them, whatever it is up here in the numerator, I would end up with 0 in the denominator, right? And we know that we cannot divide by 0. So this statement right here is just ensuring that we do not divide by 0 or get an undefined term. So easy enough here. 3 points or 3 sets of points where they want us to find the slope. All right, I'll do the first one right here for you. Now, it does not matter on these 2 points which one's x1, y1 or x2, y2. You can pick either one. So I'm just going to label for simplicity's sake. This is going to be x1, this is going to be y1, this is going to be x2, and this is going to be y2. So my slope is going to be y2 minus y1, which is 0, over 3x2 minus x1, which will be 3 minus a negative 2. Use calculator, whatever. 1 minus 0 is 1. 3 minus a negative 2 minus a negative plus a positive, I end up with 5. So the slope of that line is 1/5. And we generally leave slopes in fraction form. Whenever we talk about rates of change, which is a slope, then we'll start using more decimals, but most of the time we use fraction for that. So I want you to go ahead and quickly find the slope of these two. Right here, I'll give you just a second to work on that before we move on. But go ahead and find the slope of those 2 lines. All right, I'm going to go on with it. If you're at home doing this and you're not quite got it yet, you can always pause it and finish doing what you're doing there and then restart it up. But the y's, y minus y, 2 minus 2, and 2 minus a negative 1. Now notice this one is 0 on top and 3 on bottom. Remember, it is okay to have 0 on top. 0 divided by 3 is just 0. This is a slope of 0. That is okay. We just cannot have 0 in the denominator. Here, I've got negative 1 minus 4 and 1 minus 0, and you should have gotten negative 5 over 1, which we know simplifies to negative 5. So there's my 3 slopes. All right, nothing too difficult right there. Let's go on. And that's just where they're showing the answer. All right, here they're just showing us some pictures off one of these graphing calculators. Notice they're saying to use a square setting would give us a better idea of what the actual slope is. Sometimes it's in a rectangular shape, your standard setting, and it sort of warps it a little bit. But anyway, these are those 3 lines, negative 2, what was the, let's go back. I think that's a misprint. We got 1/5 up 1 over 5. Oh, that negative 2 is not the slope. That's just the bottom of the graph. Anyway, so we went up 1 over 5. Here was a slope of 0, which would mean we went up 0 over how many ever. It makes a horizontal line. And this one, the slope was what? Negative 5. So negative 5 over 1 means we go down 5 over 1. Okay, so whenever I'm counting out slope or I'm putting slope on a graph, I usually start with the far left point. and the numerator is the rise or the run, or the rise or the fall if it's negative. Positive means it's going to go up, negative going to be down. So here, this one went up 1 over 5, over positive 5, a slope of 1/5. This one went up 0. This one, since it was negative 5 over 1, essentially dropped down 5 over 1. So that's the graphs of those. All right, one thing you do need to note, and this is helpful in doing sort of a quick check for certain things. A line that has a positive slope always goes uphill. It rises from left to right. Okay, it's always going uphill. This is a positive slope. Positive slope. If I can make a plus sign. Negative slopes always go downhill. So that is a way to, if you're doing something or you're solving for a slope or you're drawing a line, it's a quick check for you. I know if it's positive, it needs to be going uphill. So if I see it going downhill, something's been done wrong. Okay. Slope of 0, as we just saw, is vertical. Or I'm sorry, is horizontal. Slope of 0 is horizontal. And we didn't look at this, but an undefined slope or a slope that where it's dividing by 0, which means the run is 0, is a vertical line. So positive slope, negative slope, slope of 0, and this one up and down, a vertical line, is undefined. All right, so that is good to remember for quick checks on things and is helpful. All right, so now we've talked about slope. Now we're going to use slope as part of a line and equations of a line. So there are several different forms of the equation of a line. I'm sure you remember. We've got point slope form, slope intercept, and then we're going to look at a general form. But the point slope form is what we use most often when we are trying to write an equation. When I'm being asked to write an equation, this is where the point slope form comes in real handy. And that's what we're going to be using most of the time to write an equation. So let's look at and I'm going to skip over these couple slides because it's sort of showing you that really didn't show you much right there. So here's what we got right here. The point slope form. Here is the point slope form of the equation. Notice it is very similar to the slope. If we were to solve this for m, we would divide both sides by x minus x1, and it would be y minus y over x minus x. That's sort of like the slope. The difference is here, x and y right here are going to be the x and the y that end up in your equation. X1, Y1 is any point on the line, and m is still the slope. So the point slope form of the equation, y minus y1 equals the slope times x minus x1. And let's look at how we're going to use this to create an equation. So here we go. We've got an equation that passes through, and I'm just going to leave it right there where you can't see found out. Find the equation line that passes through the point 1, negative 2, and has a slope of 3. So it gives us a point, and it gives us a slope, so it would make very good sense that we're going to use the point slope form of the equation to write this, which is this right here, y minus y1, m, x minus x1. All right, so this simply becomes x1 and y1 here, and that is obviously my m. So I just got to plug in. So y, that stays y in my equation, minus y1. So y minus negative 2 is going to be plus 2. And then my slope is 3. And then in parentheses, x minus x1. x1 is 1. 1 comes from right over here. All right. And there it is. If it asks for the point slope form of the equation, that is it. All right. Now, most of the time we don't leave our answer in point slope form because it's not a simplified form. But for certain problems, it may ask us to do that. And there you go. There's the point slope form. All right. You can look up. This is, if you look and see what they did, and I don't believe it told us to do this in the equation, they went ahead and solved it for y and put it what we call the slope intercept form, which we'll talk about here in a minute. But right here is where we left it. That's the point slope form, except you would go ahead and say instead of minus a negative, you put plus a positive. Now they put this down into a simplified form, which is usually how we would leave our answer. But we'll talk about that more in a minute. And there's the equation of the line. And we'll go on past that. We're not really ready to talk about that. All right. Now, the second way we can use the point slope form is if they just give us 2 points. Now, they've got a generalized formula here that really this doesn't make a lot of sense. I don't understand why in the book they do this. So what we're going to do is I'm going to slide over right here. And I'm going to say, okay, what if we had a line that I tell you passes through 3, -4, and -5, 7. Write the point slope form of the equation of this. All right. So remember our equation, y minus y1 equals m times x minus x1. Now, I don't have the slope. So the first thing I have to do is find the slope. Well, we just go right back to our slope formula. Y2 minus y1, x2 minus x1. And I can pick whatever. Either one can be x1, y1. Either one can be x2, y2. So I'm going to find my slope, and I've got 7 minus a -4 over -5 minus 3. And what's that going to be? 11 over -8. So there's our slope, -11/8. That's going to go right there, -11/8. And then for the second part, when I'm using x1, I could go ahead and use this point, but it really doesn't matter. Now I can ignore those because I was using that for slope. I can use either point for my x1 and my y1. It does not matter. Okay, so I could have, if it asked for a point slope form of the equation here, I could have 2 answers. I could have y plus 4 equals -11/8 and x minus 3, or I could have y minus 7 equals -11/8 times x plus 5. These are both the same equation. They are both correct and in point slope form. Now, if we were to simplify these and solve it for y like we did in the other, what you would notice is they would simplify to the same thing and show you that they are the same line. But right now, we're just going to leave them in point slope form. So that is one of the things you need to be able to do is put into point slope form to write an equation, either given a point in the slope or given 2 points. All right. So I'm going to slide back over here. I'm talking about sketching graphs of lines. Now, when we are sketching and when we're simplifying, then y'all know this, we use what is called the slope intercept form of the equation. What puts it right here, in the equation of y equals mx plus b, where m is still the slope, b now is the y-intercept. And remember what a y-intercept is. If I have a line, the point at which it crosses the y-axis is the y-intercept, right? So that number there tells you where it crosses the y-axis. So that makes it easy to sketch the line. If I know where it crosses the y-axis, say at -3, and I know the slope is 3/2, then that tells me from this point to the next point, my rise over my run, it goes up 3/2. I would put another point, then you can draw the line. All you need is 2 points to draw a line. But this is the slope-intercept form. It is a simplified version, and that's why we use it to write our final equation more often than we do point-slope form. All right. So here's a couple problems. Determine the slope and the y-intercept of each linear equation, then describe its graph. So if anytime they're giving you an equation in 2 variables and they're asking you to find the slope, what you're going to want to do is solve it for y, because once it's solved for y, that puts it in slope-intercept form. So in this one, it's real simple. I just subtract x from both sides, right? And I'm left with y equals, you could put 2 minus x. I'm going to go ahead and put it in slope-intercept form and put the negative x first, plus 2. Now, my slope is always the coefficient of the x, which we know is the understood -1. And then the tag-along number, the constant, is the y-intercept. So my y-intercept is going to be 2. Now look at this one. Earlier we talked about the equation of a horizontal line. This is going to be a horizontal line, which we said a horizontal line has a slope of 0. So if I really wanted to, I could write this as y equals 0x plus 2, where that is the y-intercept and my slope is 0. So real quickly, y is 2 right here. My slope is 0, means I go up none, over, and then I get my horizontal line. Okay? So you don't always have to have both a y and an x in the equation. If you just don't have an x and it's just a y equals, that's where we're going to get horizontal lines. And there we go. That's just saying the same thing. Now, if there is no y, this is where we get a vertical line. All right? Where there is no slope. So if I have x equals 3, well, then when I have my graph, I go to 3 on the x-axis, and that's where my line, my vertical line, I can't draw it through there very good, but my vertical line is going to go through the x-axis at 3. That's how I remember if it's horizontal, vertical. The one variable that there tells you what axis it crosses through. Y equals tells you it crosses through the y-axis, which means it's horizontal. X equals crosses through the x-axis, which tells you it's vertical. All right. And that's the one equation of a line that cannot be put in slope-intercept form because the slope does not exist. And that's all this next slide is telling you. Okay, equation cannot be written in slope-intercept form because the slope of a vertical line is undefined. However, every line has an equation that can be written in the general form. So the general form, which really does not get used much at all. So this is just sort of a note that we're going to look at here, but not really use it a whole lot. Puts the x term, the y term, and the constant all on one side equal to 0. All right, and it says A and B are not both 0. If these were both zeros, then it wouldn't be an equation at all. It would just be a number. So be aware if they do ask you general form, puts the x variable, the y, and the constant all on one side of the equation. So here are a summary of the equations of the line. The general form, which is the one that's going to be used least often. The point slope form here that's most often used to write an equation. Slope intercept form is very easy to graph, and that's how we usually simplify our equations down to. And then if it's horizontal or vertical, it ends up being either x equals or y equals. You could start it out. This is really actually in slope-intercept form. It's solved for y, but it's a more simplified formula for the horizontal line. But these are the two that's going to allow us to graph lines and also create equations. Those two right there. All right, now two special slopes, or two lines that are connected by special slopes, are parallel and perpendicular lines. And we're talking about lines in the same plane here. So parallel lines, we know, are two lines that don't touch each other, but they do have to be in the same plane. Okay, if they weren't in the same plane, two lines don't necessarily have to be, cannot touch each other and not be parallel, because they could be going in opposite directions. So everything we're talking about isn't in a plane, like a piece of paper or a whiteboard or whatever. And two lines are parallel if they don't touch. Well, what would cause them, or how would their slopes compare if they don't touch? Well, their slopes are equal. All right. So two lines are parallel if they have the same slope, which makes sense. If I have a line over here and I have a line right here that's parallel, all right, how much ever I go my rise over my run is going to be the exact same right there. If the two slopes or the rise over the run was not the same, then eventually these two lines would intersect each other. So parallel lines have the same slope. All right. So I'm going to hide that part down there. So let's do this. And this is the same thing we're doing now. Find the slope-intercept form of the equation of the line that passes through the point 2, -1, and is parallel to this line right here. So to write an equation of a line, we need to know two things. We need to know the slope, and we need to know a point. Well, they give us a point right here. So the next thing we need to know to write the equation of this line that we're looking for is we need to know the slope. Well, they don't give us a slope. They don't give us another point to find the slope with, but they tell us that it is parallel to this line right here. Well, what's the easiest way to find the slope if we're given an equation? And this is close to general form, but it's not. The easiest thing to do is to put it in slope-intercept form. It would be difficult to take this and put it into point slope form, where we're going to have an x minus some number and a y minus some number. But to put it in slope intercept form, we just need to solve for y, which is a two-step process, right? So let's go ahead and solve for y. We're going to subtract 2x from both sides, and that would leave me -3y equals -2x plus 5. And here is one part people miss this problem a lot, is when I subtract away that 2x, they forget to bring down the negative along with the 3y. That happens a lot. But now, to finish getting y by itself, we just need to divide everything by -3. So I'm going to divide each term by -3 so that I have y equals -2 over -3 is 2/3 x minus 5/3. Now, I don't care about the y-intercept of this line. Okay, that's not doing me any good. I need to know the slope, because this line is parallel to the line I'm trying to write an equation for, so I know they have the same slope. So I have a point they gave me, 2, -1, and now I know that a line parallel to this has a slope of 2/3, which means the line in question has a slope of 2/3. Now I'm going to go to my point slope form to start the equation, to create the equation. All right, even though it says put it in slope intercept form in its final version, it's a little bit easier to create the equation using point slope form. So I'm going to say y minus, what's the y coordinate? -1, so that's going to be y plus 1 equals the slope, 2/3 times x, and what's the x coordinate? 2. So that's the point slope form. Now, to finish it up in slope intercept form, we just have to simplify and solve for y. So I'm going to distribute here my 2/3 to get rid of that parentheses. So I'm going to have y plus 1 equals 2/3 x. What is 2/3 times -2? That would be -4/3. Now, to finish getting y by itself, I'm going to subtract 1. Okay? So that goes away, and I'm going to end up with, run out of room here. Let me see if I can slide this over and give myself some room. Y equals 2/3 x, slope of 2/3. Now, what's -4/3 minus 1? You can use your calculator or whatever. -1 would be 3/3. So that's going to be -7/3. That's generally how you would leave it right there. And there it is in slope-intercept form, right? If I wanted to graph it, it's got fractions, which makes it a little harder to graph, but we can still handle that. The y-intercept is -7/3, which is what? -2 1/3, which is about right there. And then my slope is up 2. So it's 2 units from there. It's not 2 tick marks, it's 2 units. So up 2, and then I would go over 1, 2, 3. And this is a very sloppy drawing, but there we go. We have our 2 points, and I can draw my line from there. So that's what that line is going to look like. But this actually answered the question over here. So there's all that. Obviously, if you need to look back at that, just hit pause and go back to it, whatever you need to do. There's them working through it. And they went ahead and graphed the parallel line and the line that they drew. And we don't have to worry about that. Now, perpendicular lines, right? We know what perpendicular lines are. They're lines that intersect and form a 90-degree angle. Okay? Now, what's true about slopes of perpendicular lines is that they are negative reciprocals of each other. And so that means M1 equals -1/M2. The easier way to look at that is if I have a slope of 3/4, the perpendicular slope is going to be the opposite. It's going to be the opposite sign. So that's positive. So it's going to be negative. And then you just flip it over. So those are negative reciprocals or negative inverses sometimes. If I have a slope of -3, the perpendicular slope to that is going to be what? It's going to be positive. And when I flip it, right, we know this can be written as -3/1. So this would just simply be a positive 1/3. So if we know if we have 2 lines such as this, and I know the slope of this line, and I know they're perpendicular, then I can calculate the slope of this other line. So we're going to use that in much the same way as we did parallel. And in fact, they don't even have another example. But if we went back to this example right here, and they wanted to know, they replaced parallel here with perpendicular, all I would do is I would find the slope of this line like we did is 2/3. And then if I'm looking to this line that goes through this point that's perpendicular to that, well, my slope would be what? -3/2. And then I would do the same thing. I would say y plus 1 equals -3/2. X minus 2. And then do the same thing. I would distribute. That would be what? -3/2 x plus -3/2 times 2 would be, or negative times a positive, that would be 6. That would be just +3. This was a little easier. Then I would subtract 1 to get it in slope intercept form. So I would end up being negative 3/2 x plus 2. That would be a perpendicular line that goes through that point right there. And that's really everything that we've got covered. You people at home, if you have any questions, shoot me an email. Join us during class for the Zoom meeting. Everybody else, I'm here in class to answer any questions. I will assign the first assignment on WebAssign 1.1. And like I said, this is the first time I've used WebAssign, so we'll just sort of see and get everybody working through that and see how that goes. But thank you much. That is it.